Hello, hi everybody. Let's learn about Etabs in one shot. In this video, we will learn about basics of Etabs, introduction, and modeling. If you have to work on Etabs, before that you should have basic knowledge of IS codes like IS 456, IS 875, all the parts 1893, 13920, and for tall buildings you should have basic knowledge of 16700. Let's go ahead with first option, file, new model, open, import. There are a variety of methods of importing geometry into Etabs. So this we will discuss later. Before that, we will go ahead with new model. There is the option of open. So for that, we can open existing model. Go ahead with use built-in setting with use metric SI. As we are working over Indian codes, so start with Indian IS 800 2007, IS 456 2000 and press OK. Custom grid spacing blank. We will go ahead with uniform grid spacing here. Why? Like we have number of grids in X direction, number of grids in Y direction, and spacing between both the grids. In custom grids, you can define it by yourself by providing coordinates and spacing like this. And let's go ahead with this one. So it will show like this. Now this is over story 4. If you have to go down, then you can go it from here. Move list, move down in list, and you have second option. This one. Click over plan here, and this option will work. Okay. Now define material. Add new material. India, concrete, Indian. Then first of all, go ahead with M25 concrete grade. Press OK. Take weight per unit volume 25. 2500. Check here. We have concrete cube strength. FCK is 25. This is modulus of elasticity. 5000 root FCK. Press OK. And then here you have a grade. Then let's go ahead with the second grade. Add new material. Then change it here M30. It will come like this. I check here. Okay. M30 is here. You can also make grade by yourself. Add copy of material like this. Then you can edit the name at this location. Like if you have to make M80, then you can change it from here itself by yourself. Press OK. Now define section properties. Before that, assume we have plan like this: 300 by 300 columns, 300 by 450 beams with M25 grade. So go here, define, add new property, concrete. As we have a concrete columns, we have column with 300 by 300 M25 grade. When defined like this. Now material properties M25 here, 300 in depth and 300 in width. Our main thing is here we can go with reinforced part. Here you have to check like it should be column. Longitudinal bars and confined bars For these, you need to also define material. Concrete clear cover is 43 and another direction. Press OK. Now define material properties. Press add copy of material FE 500 for longitudinal bar and take FE 415 for confinement bars. So take rebar 78.5, you can take 2.1 into 10 raised to power 5. Modify. This one is okay. Okay. Add copy of material FE 415. Modify 415. Okay. This is a last limit. You can also reduce it from like 650. This says 600. These are the default values. Press OK. OK. Now again go to define frame section. Frame section. C 300 by 325. Modify it and modify reinforcement part. FE 500 and FE 415. Press OK. Modifiers, these we can discuss in different video. Like it depends upon the structure and also depend upon the caudal values and which we have to use and where we have to use. Currently, we will go ahead with 100%. Press OK and OK. Now we have to define beam. Press add copy of material, or you can also add new material, a new property. B 300 by 450 we need. M25 depth is 450. Change from here beam 60 by 60. This is a cover to longitudinal rebar group centroid. If we are using 2 to 3 layers, then from that centroid we need to take cover. So currently we can go ahead with 60 mm. Press OK. Now OK. Press OK. Now we need to model these beams and columns at these locations as per this plan. So I made this plan same as per the grids we have here. I have prepared this plan similar to Etabs grids so that there should be no confusion to figure out the location where we have to place column. So these are the shortcuts, and we can also go from here, draw beam columns, quick column, and here we have a shortcut option, draw quick column. We just have to click here and column will be there. Just click, just click at these points where we have to model the column. And for beams, you have two options. One is you just have to take beam from this location and choose a property be 300 by 450. One is this, as this is a similar geometry and we have grids are also there. You can also draw columns, draw beams from here. You just have to drag it everywhere. Beams are there. If you would like to set in perspective toggle view, and see like this. Here you have option set view options. These options are required, like if you have to see only columns, you have to see only beams, if you have to see all the things, you just have to check these options. If you have to, like, now I don't like to see the columns at this location, I would like to see only the beams, then you can just uncheck the columns, only beams visible. If you will uncheck the beams, then only columns are visible. These are the other object assignments. As we are working over it, you will get to know which option we have to use. So currently, let's go ahead with this one. Okay. We have beams. We have to see the properties now. So for that, go to object assignments, sections, press OK. It shows 300 by 450 beams are there. You see in the 3D, shows 300 by 450 columns are there. Sorry, 300 by 300 columns are there. So now the next part is we need to model the slab. For that, you have to go define section properties, slab section, add new property. For example, I have to use S slab of thickness 135, M25. Take a grade M25 here. Currently, we will go ahead with membrane slab 135. Press OK. OK. Now we need to model a slab. So for that, as this is a rectangular geometry, you can draw rectangular from here. Click and drag. Click and drag. You have this thing you need to keep in mind, that you have to break it from the beams location. If you will model directly like this, then for your ease, you can split it from here, this location. Edit shells, divide shells, we cut floor object at selected frame object. Press OK. And if you see, this is different, this is different. And now let's learn one more command. If you like, I have selected these three slabs. Now, if I need to replicate it below, as this is a 6 meter, then add it, go replicate. This is in Y direction, so press -6. Here we have. If we have a typical structure, means all the floors are similar with respect to the loading, then you just need to complete one floor and you can replicate that floor above or below, whatever. So now, before assigning any type of loading, you just need to define load pattern. Go to define load pattern, then floor finish, super dead. Floor finish is in super dead category. Similarly, wall is also in super dead category. If you have any sunk loading, then that is also in super dead category. Self-weight multiplier should be 0 for loads other than dead load. Now, earthquake, EQX, take seismic and define code from here. For earthquake, we have 1893. Similarly, in bi-direction, earthquake, we have 1893, add new load. Now we need to define wind loads, wind X, 875 part 3. Change wind 875 part 3. Add new load. Wind in y direction similarly. Add new load. Whichever categories you have, whether water tank load, machinery load, any type of loading, you just have to define here. Then press OK. Now, if I have to assign live load 2 kilonewton per meter square, then I just need to select the floor, go to assign, shell load, uniform, live, and directly fill the value like 2 kilonewton. It will be visible like this. Now, if I need to add floor finish of 1.5 kilonewton per meter square, then you just need to assign like this. Now, if I have internal walls at this location, now suppose we have internal walls with 110 mm and external wall with 230 mm. So we need to do the calculation for those walls. Now need to assign wall load. Select all the internal beams. For internal beams, we have 115 mm thick walls, and for outer, we have 230 mm thick walls, as we have assumed. It depends upon the architectural planning. In actual scenario, you just have to check with architectural plan. Now see the height, edit story. We have taken earlier 3.2 meter height. So we have to do calculation as per 3.2 meter. 3.2 meter total height and 450 mm thick beam, depth of the beam. We have to reduce that because at that location we don't have any wall. So it comes 2.75 with density 19.2 and 20.8 for plaster. It comes 13.75 for 230 and for 115 it comes 7.62. We just need to assign 7.62 in case of tunnel walls, distributed wall 7.62, apply. Now we have to select outer walls. And here we have to assign 13.75. It comes like this. Now, story 1 is completed. As we are also using earthquake loading, so we need to assign diaphragm for the floor. Assign shell diaphragm, as this is a rigid plan. So take it as rigid diaphragm. Okay. If you have more cutouts and also you can check with 1893. If it does not fulfill the requirements as per 1890, in that case you have to use diaphragms accordingly. Here we are using rigid diaphragm. Now as one floor is completed, so we just have to replicate it above. Edit, select this completely, edit, replicate to the stories above 2, 3, and 4. Apply. If you see, now it will come like this. Second, third, fourth. All have similar thing. You see in the extrude view itself, will come like this. So the geometrical part is done. Now go to base, select the points and assign the port conditions. Do it fixed at the restrained at base location. Now it looks like this. See, as we have replicated all the things to the above floors, but we also replicate over the last floor all the wall loadings. But over the roof, we don't have any internal walls, so we have to remove these loadings from the inner walls, and for the outer walls we just need to assign parapet wall loading. This is the major thing that we have to do, so that loading should not be doubled. Delete this, select these. You just need to apply parapet load, which if we have a parapet height approximately 1 or 1.5 meter height, then it comes approximately 5 kilonewton. So previous selection, assign it as 5 kilonewton only. Apply. It comes like this. Now as per the loading and as per the geometry, it is completed.